We're going to be talking about now even and odd functions. So let's look at what the definition of an even function is and get some understanding here. So a function f is even if each x in the domain of f is as follows, meaning if I plug in a negative x, the output is the regular function. So I input a negative x and the output is the original function. So for example, f of x equals x squared. See, if I plug in negative x, if I square negative x, means like negative 1 times x. So if I square negative 1 times negative 1, which is just 1, right? So that's just 1x squared. So this is 1x squared, but then x squared, isn't that just the original function f of x? So see, by definition, negative x squared, or I'm sorry, negative f of x, I plug in negative f of x, and the output is f of x, just like what the definition says. So when that happens, that's called an even function. So therefore, f of x equals x squared is an even function. Now, if you graph an even function just by looking at the graph, you can also determine if it's even, because if you draw a line down the, basically it's the line x equals 0, the y-axis, it will always be symmetric with respect to the y-axis. So if this is 1, 1, then this will be negative 1, 1. This is 2, 4. This will be negative 2, 4. So it will always be a mirror image, meaning if I cut this in half, I can fold this over here and it will be the same. Okay? And odd functions. An odd function is when you plug in negative x, but the output is negative of the original function. It's the opposite of the original. So for example, if I have our function x cubed and I plug in negative x. So if I plug in negative x, I get negative x cubed. Or negative x cubed, let me get my pen here working. So negative x cubed means negative x times negative x times negative x. Well, a negative and a negative is a positive, and a positive times a negative is a negative x cubed. Okay, so that's why this is negative x cubed is negative x cubed. And this happens to be negative of the original function, right? This part right here is f of x, and then on the outside is negative. See? And that's why the answer is negative f of x. So we plugged in a negative x, and the output was negative f of x. So by definition, that would be an odd function. So f of x equals x cubed is an odd function. And what does that look like graphically? So if a function is odd, the way that you can see it visually is the graph will be symmetric with respect to the origin. Say, okay, what does that kind of really mean? I guess what you can say is if you were to cut this in, if you were to cut the graph in half right now, okay, that means if you were to reflect this over here and then reflect it again across the x-axis, reflect it across over here, and then you would have this guy now. So a symmetric across the origin is a double reflection. You reflect across the y and then across the x. Another way that you can visually see that is, say if this is the points 1, 3, then if you want to know if it's symmetrical with respect to the origin, then the point that's symmetrical to that would be, you just change the signs and then you flip them right there. So that would be negative 3, negative 1. Okay, does that kind of make sense right there? So symmetric across the origin is if this right here is xy, then you flip it. So then this right here would be negative y, negative x. You know what? Sorry, change that. That's not true. It would be negative x, negative y. So actually, let me just change that part there. No confusion right there. So this point right here would be negative 1, negative 3. And so then if you had the point xy, it would be the point negative x and then negative y. So that's how I know if like these two points were symmetrical with respect to the origin. Okay, so let's do some examples now. All right, let's determine whether each function is even or odd. And if they are, then you say they are. But if it's neither, meaning if it doesn't follow that pattern, then we're going to say that it's neither. So this is the definition that we're using. If I plug in negative x, and if of x pops out, that's going to be our even. And if I plug in negative x and a negative of the original function pops out, then that's an odd. So let's do this one. Let's find out what happens when we plug in negative x. So if I plug in negative x, I get the absolute value of negative x. We know that the absolute value of negative x is just x, right? I mean, does this make sense right here? And x is the same thing as the absolute value of x. Right? I mean, this makes sense, right? I mean, the absolute value of negative x is the same thing as the absolute value of x. I'm sorry. And that should make sense because the absolute value doesn't always make the answer positive, right? It always makes it positive. So if I take the absolute value of negative x, that's the same thing as taking the absolute value of x. And this happens to be f of x. So by definition, check this out right here. I'm a big old eraser, man. This would be absolute value of just x. So by definition, I plugged in a negative x, and out came the original function, so it would be even. And if you wanted to see, oops, hold on here, like I actually made the graph so that you can see it. Let me just put this right over here. Here's what the graph would look like. And as you can see, if you draw a line down the middle, it's going to be symmetrical with respect to the y-axis. Okay, so if you just cut a line down in half, it's going to reflect it right there. How about this guy right here? Let's go ahead and plug in negative x and find out what happens, right? If one of these two things happens, we can say it's either even or odd. So g of negative x equals negative x cubed minus negative x. So we determined that from the last example, or at least in the introduction of being odd, that this is the same thing as negative x cubed, right? And this right here is a positive x, right? Okay, so just by looking at this right now, you probably are thinking like, oh, that's not the same thing. Okay, don't be so quick yet. However, if I factor out a negative 1, like this, I get x cubed minus x, right? X cubed minus x, isn't this right here g of x, right? X cubed minus x is g of x. So if I replace this and say, oh, this is negative g of x, and that just fit the definition of being odd. I plugged in g of negative x, and the output was negative g of x, just like right here. F of negative x, if I plug that in, out came negative f of x. So this right here would be odd. And to see that graphically, let's move this over. I have that right here. Bam. And if you draw a line, actually not really drawing a line here, but you should be able to see that symmetrical with the origin means, again, like if this is the point 1, 2, then you go negative 1, 2. If this is the point 3, 8, then negative 3, negative 8. So you should be able to recognize that this looks like it's odd right here. Okay. I'm going down here to part C. Is it even or odd, or neither? Well, let's see. Let's plug in negative x. Then I get negative x squared plus 1, which is x squared plus 1. So which is just f of x, or I guess you could say like h of x. So I plugged in negative x, and out came the original function. So by definition, that should be an even function. And I have the graph right here to show that. It's a quadratic, and we all know that quadratics that are on the y-axis, you know, it's always going to be symmetrical. So this one is even. Okay. I guess I should actually be writing this down. So this right here was even. The first one up here was even. And this one right here was odd. And last but not least, D. You know I had to throw in one that's neither. So this would more likely be neither here. So let's check this guy out. Let's plug in negative x. Hold on, let me just do this. Okay. So let's plug in negative x. F of negative x equals negative x cubed minus 1, which is negative x cubed minus 1. And you can factor out a negative, so that's negative 1 times x cubed plus 1. But wait a minute, this right here is not f of x. So it doesn't fit the pattern. It's not odd or even, so this one here would be neither. And that concludes that.